Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And previously we looked at how to call the methods of a Java object from C++ using JNI. And we looked at both the static methods, instance methods, and static methods. And now obviously the next step is to look at how to call interfaces. Now, in general, interfaces cannot have a state, right? They can't have instance variables, but they only have methods. And the methods prior to Java 8, the methods could only be abstract methods. But since Java 8 onward, interface can have a static method and also default method. Default method is basically an instance method. It's not abstract. It's an instance method that can allow us to include implementation. So default methods have bodies, right? Have a body implementation. Abstract methods don't have an implementation, don't have a body. And static methods are also not abstract, which means they should have a body, okay? So if we can call the methods of a Java interface from the C++, then we can also handle lambda expressions, because if an interface only has one abstract method, it can be considered as a functional interface, and a functional interface can be passed around as a lambda expression. So we can use a lambda expression to construct an interface that only has one abstract method, okay? So again, the process is very similar to basically calling the method of an object, right, of a Java class, and abstract or default or static. So calling a static method in an interface is very similar to calling a static method in an object, right? So the very first thing that we need to have a reference, a pointer to the meta information of the object of the interface. So we ask JVM to find the class, and we provide the class path description of the interface. Note that we are still using class here, not an interface. We don't say find interface, it's just find class. And then we get the method ID, and if it's a static method, we use the get static method ID, okay? So for instance methods like the default or abstract ones, we use get method ID, and for static ones, we use get static method ID. And we pass a reference JClass, the name of the method, and the signature of the method, which includes the signature of the parameters and the signature of return type. And then if the return type is a primitive, we use call the type of the primitive, double, int, float, boolean, etc. method. And then we pass a reference of JObject, all right? JObject. If it's a static method, we pass a reference of JClass, and we use call a static double method or call a static int method, etc. Again, very similar to how we call a static or an instance method of an object. So if the return type is an object, it's not a primitive type, we use call object method or call a static object method. This means this method returns an object, and we pass a reference either to the JObject or a JClass, depending on whether the method is a static or non-static, right? So here I have a simple example of an interface in Java. It's called math function. It's an interface. It has one public abstract method, and note that the interface is public. And because the interface is public, all the methods are public by default, right? And so I have one abstract method value, which takes a double value and returns a double value. And then the next method is a default method, and it has to have a body, so it cannot be terminated by semicolon like the abstract one. So I just call it value scaled. So I take the x and call the value method and then multiply it by 5. Now I added a static method here, and this method takes a math function, which is an interface, and returns another math function, returns an object, an interface, right? And I call it function scaled. And what this does is it takes this function and multiplies the value by 5. And you see the return type is a lambda expression, because this math function only have one abstract method. So I can pass it around as a lambda expression, or I can assign it to a lambda expression. All right. So the old way of returning this math function from this method is to use anonymous class. So return new math function and then implement it. But the new way, which is more concise and more readable, is just use a lambda expression. All right. So let's set it to Eclipse and try to work with our JNI and call these methods from C++. So in the Eclipse, I created the package test14, and in this I have basically created this interface math function. And as I mentioned, the old way of basically implementing this static method was to use anonymous classes, right? Return new math function, and we have to provide an implementation for this method. So this takes x, and this returns basically func.value x and then multiplied by 5. So this is the old way, but the new way is just because this is a functional interface, which we can just pass it around as a lambda expression, right? So this is only one abstract method. If it had two abstract methods, we could not use lambda expression, but because it only has one abstract method, we can use as lambda expression. So here we just say x goes to func.value x times 5, right? So this is how we can pass it around as lambda expression. So I'm going to create a new class to test this calling the JNI methods, calling the methods of this interface from C++. So test interface call. And let's have a main method. So here I'm going to have a method test1, and in this test1 let's define it as a public static void test1. And what do we want to do? Let's create a math function func1, and again let's do a lambda expression math.sign of x. So I construct this interface as a lambda expression because it is in fact a functional interface, because it only has one abstract method. We can annotate it. Basically, we can enforce this behavior by using the annotation at functional interface. So if we add another abstract method, the compiler complains then, because it says this annotation only allows one abstract method inside this interface. All right. So the intended use of this interface math function is as a lambda expression, to have only one abstract method. All right, then I'm going to have a basically I can have a method, a static method. Let's call it call value method. Call value. And then I pass func1, and then basically the value of the x. Let's say I want to have I don't know, 2.1, and this is going to return a double. So func1, so double result, and then I'm going to do a sysout on the result, and then I also am going to double let's say val1, and I'm going to actually evaluate it directly in Java, func1.value and 2.1, and then sysout Java result plus val1, and here let's say C++ result equals plus. And now we need to implement this function call value, which is going to be a native function, public static. It's going to return a Java double, a primitive, public static double call value, and we're going to pass in a math function func and then double x. All right, so this is our native method, public static native. So this is going to be a native method. So we create our interface as a lambda expression all right, and then send it to C++ with the value for x, and this in C++ we're going to call this value function, value method, and get the result, and then send it back to Java. All right, so let's see. So the next step is to go to our C++ perspective, select our Java file, and then run the Java H on this, and it's going to create the header file and put it in the header folder here. So it's going to, the name should be test14 underscore test interface call. All right, and then we're going to, in the source folder, I'm going to create a new CPP file, a compilation file. Let's call it call interface method.cpp. And again, the very first thing that we do is we include the header file. So header test14, and then we copy and paste the prototype of the function, and then we do the JNI environment, let's call it JVM. J class is the pointer or a reference to the calling class, which is test interface call. J object is our function, and J double is our x value. All right, and again, J double directly maps to a C++ primitive, so we just treat it as a primitive. And this function is a J object. This is an instance, right, of the interface. So what do we need to do? Step one, get the J class of the interface. So J class math function class is basically JVM. Find the class for me, and what is the class? It's what is the signature or the class path? It's in the package slash class name. So package is test14, and then it's math function. All right, so this is the class path description of this. It's inside this project in the source folder. The top package is test14, and then the name of the class is math function, which is an interface. And then in step 2, what we are going to do is we are going to get the method ID, the method that we want to call. So J method ID. And again, interfaces don't have instance members. They don't have any instance fields. So we never use a J field ID on interfaces. I mean, interfaces can have a static fields. So yes, we can access the static fields, but they don't have any instance fields, right? Because an interface doesn't have a state. So J method ID, we are going to get the value. We're going to call the value method. So we get the method ID of the value. JVM get method ID, and it's not a static method, so it's just a regular method. It doesn't matter if it's abstract or not. So we pass in the reference of the J class, math function class. The name is value, and then the signature is again, the signature should include the parameter type and then the return type, and the parameter type is double. The return type is double. So we can go and quickly double check it. If I go to the Java perspective, bytecode, and click on this value, and then I zoom here, you see the parameter signature is double. The return type is also double. So back to the C++. All right, so we get the method ID. Step 3, let's call it. So if I ask again JVM to call this method, call, and this returns a primitive which is double. So call double method, and we pass a reference of J object because this is not a static. This is a instance method of the interface. So we have to pass a J object reference, which is our function, and then method ID. It's the value ID, right? And we also have a var parameter for the value, actual value of the parameters. So here is just this J double X. And this returns a double, so J double result. All right. And again, J double maps to double, and I always prefer to use the JNI types because then it matches directly the return type. And we need to return this result. All right. So let's compile. compiles fine. Let's copy and paste the dynamic library to our Java project. And then let's go back to this test class and run test1. And it throws an unsatisfied link error because we need to load the dynamic library into the memory before running. So system.load library, system.load library, and the name of the library is native_c. So let's run it one more time. And the JVM crashed. So let's figure out why the JVM crashed. Let's look at the log file. Let's see, Java test call value, call double method, J object, J method, JNI call double method void. Why is this happening? So let's see. In the math function, we have this method value. So we are passing this reference call value and then 2.1. And then we are returning back a result. So we get the find class, okay, and then J method ID value. Oh, okay, so we have to, yeah, so it's just a name. I was specifying this parentheses, which is wrong. We should just give the name. So let's compile again and then copy and paste the dynamic library. And then go back and run our Java code, and as you can see, it works fine. So I'm just going to delete this log file. So now we can basically call this abstract method, which is an instance method. It's not a static, from this interface, right? And again, the process was very much similar. We find the class, get method ID, and call double method. All right. But because this is a functional interface, we can actually basically directly pass a lambda expression to it. So call value, and then let's say x goes to 2 times x, and with the value of -1.5. So we can directly pass a lambda expression because this is a functional interface. So if I run this, it still works. So it takes -1.5 and multiplies it by 2 and returns the value -3, and the calculation is actually done in C++. Okay, so this was how to call this abstract method. There is absolutely no difference with calling a default method, because the default method is also similar to an instance method, so the steps are the same. So but we can try it again. Public static native double call value scaled, call value scaled. All right, and I need to select my Java file and update the header file again. So test14 header file, and then copy and paste it to the CPP file, and then I need to provide an implementation. So JVM, J class is the reference to the calling class, test interface call, J object is my function, and J double is the X. And more or less we're going to do the same thing here. All right, so let me just remove these. So we have to get the J class reference to the math function interface, because we want to call a method in this interface, and then J method ID is now value scaled, right? Again, it still takes a double value and returns a double value. So the signature is the same, the only difference is the name, value scaled. So if I compile this compiles fine. Let's copy and paste the dynamic library and go here. Let's create a let's remove this. Let's create another test, and I'm going to call it test2. And in test2 I'm going to call value scaled, and also here value scaled. So test2. So in this default method I take the actual value and multiply it by 5. So let's run this. Yeah, so now we get 4.3160. So if I run test 1 and test 2, the difference should be a factor of 5. Yes. And as you can see, we are able to call the default method inside the interface from the C++. Now the last one is the static method. So this static method is actually going to return a object. So let's try to see if we can actually work with it. So in here I'm going to say public static native math interface and call, what was the name, function scale. Call function scale, and the parameters are going to be the same. So we take a math function and a double value, send them to C++, and then it should be math function, and then the C++ is going to send us back an object, math function. All right, so let's see. So obviously I need to select the Java file, run the Java H, and update the header file. And now we have this one, and note that here the return type is now JObject. All right, so let's go back to our CPP, and the JNI environment is JVM. JClass is a reference to the calling class. JObject is the function that we are sending to C++, and JDouble is X. Actually, we don't need to send, we don't need to send an X here, right? So we just send the math function, and we call this method. It takes this and returns a lambda expression. Okay. So let me update the header file again. And then copy and paste to C++. So JVM, JClass is the calling class, and then JObject is the function that we are sending to where we are sending to C++. So JClass is the same, and then for the JMethod ID, we have a function scaled ID. We ask our good old JVM to get, but this is a static method, right? Get a static, and then get a static, and then this method returns an object, right? So get a static object, so get a static method ID, right? So get a static method ID, and we send a JClass reference, which is the math function class, the name and the signature. So let's see. So what is the name of this method? Function scale. Let's just copy and paste it. And what is the signature? So we have to provide parameter signature and then the return type signature. All right. So I'm just going to zoom in a little bit here. So it takes a object, which is basically a math function, and returns an object, which is a math function. So each object has a signature that it starts from L and ends with semicolon. And the math function signature is inside so the package is test14 and the name is math function. And it's basically the same here, test14 math function. All right, so again, it's always best to just write the L semicolon first, and then figure out the class path description. So we can quickly check it by going to our Java perspective, bytecode, click on this function, click on this method, and then zoom on the basically, okay, I need to extend this. So let's see. So it takes a parameter of type L test14 math function semicolon, and then returns a L test14 math function semicolon. All right, so our signature is correct. And let's go back to the CPP file. So we get the JMethod ID, and then once we get that, we need to ask JVM to call it. So JVM and call, first of all, it's a static method, And then the return type is an object, right? It's not primitive. So call a static object method. And J class, which class are we going to call the method? It's the math function class. What is the method ID? It's the function scale ID. And we have a var to provide the parameters. And the parameter is an object function, right? So func. And this returns a J object. So J object result. And once I get this, this function expects us to return back a J object, so we just return result. So let's go to the C++ perspective and compile. Compiles fine. Let's copy and paste the dynamic library to our Java project. And then go back here. So I'm going to create a new test. Let's call this test 3. Let's comment this one and then test 3. So I start with the math function. Let's say a simple one like 2x, and then what I'm going to do, and then I create another math function func2 by calling the math function dot the static method func1. all right, and then Java result func2 dot value, and let's evaluate it at 2.1. And then we call the function scaled, and this we send our func1 there, and then this returns a math function, and let's call it func3. And then the result is we're going to call the func3 dot value 2.1 and compare the results. all right, so let's see. Yeah, it works fine. So we were able to call the static method, and basically what happens here, we take this 2x and multiply it by 5, 10x, and then we evaluate it at 2.1, which should be 21. And the same thing in C++. So we basically get the J class, and then the method ID, it's a static method, so get a static method ID, and then the reference to the J class, the name of the method, and then the signature, which includes the parameter signature and the return type signature. And then when we ask JVM to call the static method, because the return type is an object, we say call a static object method, and then we provide our J object as a parameter to this call. And then it returns a J object, right? It returns a J object, and this is exactly what this function expects us to return. So we just directly return this result, and we are able to pass in a lambda expression, right? And basically, instead of having this func1, I could just directly pass a lambda expression. And the C++ can easily handle this, because a lambda expression is a functional interface. It's always backed by a type, which in this case is an interface math function. And if I run this, I should be getting the same result. Yes. So I hope you enjoyed this lecture and fully understand how interfaces work, how we can call them from C++. Please stay tuned, and I'll see you in the next one.